it's not a direct area of artificial intelligence, but a lot of work is happening in image processing. So in this, we were speaking about like cognitive areas of machine learning or artificial intelligence. The difference between cognition and recognition, I just told you. When our brain, how does our brain work? Like when we see the person for the first time, our mind is going to cognize that pattern is, recorded in our brain. And when we see the same person for the second time, our mind is going to recognize, we call it as recognition. So first time when your mind is going to cognize, the pattern is, your database is trained with that new pattern. And then the second time you see it is going to do a pattern matching there. It does image processing, and then it gives you a match. So this is one area of AI. And like we human beings go around, okay, we have the sense and touch sense and all that, and that mobility in us that can be captured with an area of artificial intelligence, which we refer as robotics. Okay, the movement of human can be captured in the field of robotics and artificial intelligence. Now to go further, what happens is we have, as I told you, our mind is going to do the mapping and all that, and we call it as pattern recognitions to identify the pattern either in our in our mind, what we say, and that leads to an area of machine intelligence. Naina, my slides are visible, Naina? Hello? Hello?
Hello, ma'am. Hello, ma'am. Yes. It is visible, ma'am.
Yes, you can you say this? What is the most powerful problem solver in the universe? The slide is visible, right?
Yeah, ma'am. Visible.
Yes. Okay, ma'am. Fine. I'm still on the slide. I'm still on the slide.
It is visible now.
Okay.
Hello, ma'am.
Yes, ma'am. Got it. And so continuing with pattern recognition, we say we have another big area which is called as machine learning. See, one thing I would like to tell you, the concept of cognition and recognition and all this lies in our brain.
Hello, ma'am.
Yes, ma'am. Yes, ma'am. Hello. Someone said hello. Okay, continuing with the slides here. Machine learning, as I told you, see, artificial intelligence broadly can be classified into two main groups. Whenever we say we have the symbols and we have the patterns to be recognized. Yes, ma'am?
Yes, ma'am. Can you hear, ma'am?
Yeah. I'm continuing. In case there's anything, you can interrupt. All right. So artificial intelligence can be broadly classified into two major domains, as we are discussing. Whenever we say you're doing the image recognition and all that stuff, we call it as symbolic reasoning. And then when you say a database type of representation, wherein the data is being processed and analyzed, that is ML or machine learning. So AI, broadly, we can say database type of representation, we call it as machine learning. And then symbolic representation, like your robotics, your computer vision, your image processing or pattern recognition, all these come under the symbolic type of representation. We call it as symbolic learning. So now AI could be symbolic learning or machine learning. Now in symbolic learning, as I told you, image processing, robotics, computer vision, it goes like that. And in machine learning, it is more with your the way your brain works, the way you try to capture the images or analyze the data, how we think in that direction. If you start working, then that we call it as a neural network type of representation. In neural network, as all of us know, we have different layers. One we call it as an input layer, the other one we call it as an output layer. In between, we have got the hidden layers, right? More the number of hidden layers, deep is the knowledge of the data. If you have the hidden layers in more depth, we call it as Okay, it is there is a lot of content to be processed when you have there are more hidden layers, we say, and that issue wherein these hidden layers data is being conceptualized, the concept of learning in machine learning, we refer it as deep learning methods. In deep learning, again, we have got two types. We call it as CNN and RNN. CNN is a convolution neural network type of representation, and RNN is recurring type of neural network. What do you mean by convolution type of neural network? There again, we have something called as your object recognition. Probably some of you would have done projects using YOLO and all, and you say we are doing the object recognition, identifying objects, live objects in images, in videos and all that, which is trending these days. Object recognition is a field of CNN, convolution neural network. And of course, computer vision plays an important role in convolution neural networks. So neural networks remember, okay? They remember. And like if I ask a question, what dinner you have last night? At least some of us will remember. So that concept of remembering, okay, of having that getting recorded in your mind and producing that we call it as a recurring type of neural network. Okay, remember the recent past is the feature of your recurring type of neural network. So just a minute. Not audible. Okay. From when? Now is it? Okay. Okay. Hello, Naina. Naina, am I audible?
Yeah, ma'am, audible.
Okay. So someone said not audible. So just, okay. The screen, hope you can see, right?
Yeah.
What is the most powerful problem solver in US? That is on my screen. Okay,
Yeah,
fine. So now we are continuing with convolution neural network and recurring neural network. So we said in recurring neural network, we try to, have the limited past to be repeated, to be remembered. Okay, that's about your recurring neural network. And now, as we said, object recognition using different type of softwares, you do image processing, object recognition, everything. And one example, YOLO and all, the most trending these days is with your convolution neural network. So now I think I have touched upon most of the areas of artificial intelligence. With this introduction to artificial intelligence, telling that it is the biggest branch of computer science and engineering, and there we have in AI two ways of representing symbolic learning and machine learning. Symbolic learning with robotics, image processing, and machine learning is more of database type of representation, and wherein we have got the deep learning statistical representation, NLP, speech recognition, CNN, RNN, all these concepts are with machine learning methods. And of course, when we say learning, we have got different types again, supervised learning, unsupervised learning, and reinforcement learning, which I'll take you in depth with those machine learning concepts. Now, this is about AI. So what I spoke is not there on my slides, and what is on my slides, slowly I'll take into those slides, the content, okay? If you can see here, as I told you, there are majorly two types of representation. Either we can say it could be the human brain, how it works, and we call it as an evolution type of representation. The other one, we call it as neurocomputing, okay? So whenever you want to build a problem, you would be trying to mimic. If I say AI, it is like you're mimicking human brain, okay? And you're trying machines to learn like how we learn. So this term learn is directly related to training. You have a database, you train that database. When you train it, the database is going to learn. That is, you're going to give the cognitive capability for the database, wherein it is trying to understand And then you're going to do some analysis on that available database, and you're going to do some predictions, or you're doing some analysis. You're going to apply some machine learning models. Okay, so making machines think like humans. Okay, so that issue we call it as neurocomputing. More of neurocomputing. What I said, CNN, NN, and RNN, and all these things are trying to mimic our brain directly, whereas robotics and all are more of symbolic learning. Okay, so neurocomputing is trying to mimic how our brain works. You're trying to make the machine, you're going to train the machine in those terms. The other issue is evolutionary computing. This I just now told you. Over time, how this took a turn and how we have landed up in artificial intelligence, incorporating the latest things. Okay, I'll be taking you through different artificial intelligence applications. For example, when you use your simple iPhone, you have got that Siri. Siri is also an intelligent way of responding, right? So either it could be Facebook or your Twitter or your even Netflix. Very recently, due to lockdown, probably it's a very popular thing that everyone will be using Netflix, seeing movies. The rating of the movie is also based on the prediction, based on this artificial intelligence being incorporated. The review of one particular movie, even before the person watches the movie, can be predicted using this AI model. Okay, that is the latest trending things in Netflix. You say, I have still not watched the movie, but what is your review? They can tell you. What is your review? They can tell you based on the available reviews, what you have already done. And people, they analyze the online behavior of people, and they try to do some analysis on that. That is one big, application these days. So the next slide is about taxonomy. So as you know, the meaning of taxonomy is technical classification. Okay, technical classification, we call it as taxonomy. Now, computational intelligence or soft computing, if you look into how technically they could be classified, we have three major branches of computational intelligence. We call it as neural networks, evolutionary algorithms, and fuzzy systems. Okay, these are the three major branches of computational intelligence or soft computing. Now again, evolutionary algorithms, we have got much more like evolutionary programming strategies, algorithms, and genetic programming. So if you look into this in this main taxonomy, neural networks, just now I told you, you try to make the machines think like humans, like your neurocomputing type of representation using the hidden layers in deep learning and all that stuff is about neural networks. And later, even of course, the cognition, recognition, cognitive sciences, everything comes under this issue of neural networks. So it is more of mapping your brain type of representations. And the other part here, you can see fuzzy systems. Now, when I say fuzzy, it's a very big domain of artificial intelligence and most toughest domain of artificial intelligence. You know why? The meaning of fuzzy itself is difficult. What do you mean by fuzzy? See, fuzzy means, I'll give you an example. If I say, this boy is very tall, then I say, how tall is this boy? Maybe he is around 6 feet tall. Okay, then I make another sentence. I say, look at that basketball pole. Okay, the basketball pole is so tall. That's also very tall. Now I said the boy is very tall, the basketball pole is tall. Then do you mean that the boy is as tall as the basketball pole? No. There are different gradients. It could be for human beings or it could be for a pole. There are different gradients. Okay? Similar to that, if you take another example, I'll ask you a question. Okay? I'll say you're a good person or you're a bad person. Fine? So some of you will say, yes, I'm good. And the same person will say after some time, no, I may not be full 100% good. I'm little bad. Then you say little good, little bad. You say 80% good, 20% bad. Like you're not properly, defined about what exactly we are. Right? We say fuzzy. That is, I'm trying to tell you, fuzzy systems are one complex representations where you don't have a proper definition. You cannot say it is this exactly. It need not be that. It could be in the range. It could be 50%, 70%, like that. We make some compromises for deciding the result. Okay. So fuzzy systems, normally when you do your research, it is full of mathematics and all that. It's pretty difficult to handle fuzzy logic and all that. But it's a very interesting topic. You try to do prediction for unpredictable type of things, that is fuzzy. And getting into different domains and applications of artificial intelligence, we say numerical combinatorial optimization. We have something called a system modeling and identification. And we do have much more like...
Excuse
yes, ma'am.
me.
Yes, ma'am.
Roshan sir, please. Okay, ma'am. You can continue, ma'am.
Okay. Yes, ma'am. We are talking about different domains and applications of AI. So we see numerical combinatorial optimization as one, system modeling and identification as one bigger domain. Obviously, engineering, design, and data mining and machine learning. You can see here in artificial
Kavya.
intelligence. Yes, ma'am.
Kavya, ma'am, sorry.
Yes.
Your slides are not visible, ma'am.
Not visible. Okay. Can you see domains of application? No.
No, ma'am.
But why is that? No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am. Yeah. Now it's visible, ma'am.
Yes, ma'am. There will be some delay when I start.
Yes. Okay.
Okay. Ma'am, can you see the slide number 7, domains of application?
Yeah, ma'am, it is visible.
No, ma'am.
Okay, okay,
No.
fine. To continue, that's what I wanted to tell you here. Domains of application is like numerical, combinatorial, and all this. And you can see here we have data mining and machine learning here. Machine is one domain of application of your artificial intelligence. Okay, so that is how it goes with machine learning. Now, to get into each one of this in detail, first of all, every time whenever you have any method, you need to have a count on the performance. So right, we would have a wide range of problems here, and then you can see these are different things, different parameters which you can see with related to performance in your artificial intelligence. Now, to get into the different problem solving techniques, so this is what we want. Okay, these are the things which artificial intelligence, you can think of doing research papers, you can think of doing different types of, you can write articles and you can explore much in these areas. So normally problem solving techniques, we have got two types. We call it as hard computing and soft computing. So we have different type of models here. We say precise models and approximate models. In precise models, we have got something called a symbolic logical reasoning and traditional numerical modeling and search. In approximate models, we have got something called as approximate reasoning and functional approximation using a randomization search. So these are the two computing methods, and that's how here ML comes into picture. So to get into our topic of machine learning, as you know, normally how is that humans learn? Based on experience, okay? Based on your cognitive representation, based on your memory, based on that, you're going to train your mind. The same thing happens in machine learning. So we give experience, which is called as data, to the computer, and then we call that data as a training data. On that training data, we try to apply different methods of machine learning like supervised, unsupervised, and reinforcement learning, which have got different algorithms in them, like your KNN algorithm, Bayes algorithm, Bayesian algorithm. You have got a lot of algorithms there under each category, and that will be your learning model. Apply those models and then prepare that for action. So we have got, based on the past experience, we have the data, we try to give some test data and then check whether how well it is going to react with the available data, and we are going to come to some conclusions based on the model, whatever we are going to decide. These models are decided based on the type of data, Supervised learning, the data is different. Unsupervised learning, the data and the goal, how is that we have to do, that is again different. So those are different areas of machine learning. So if I have to get into detail with the areas of machine learning, supervised and unsupervised, in further slides, I'll take you through the process. To get into the ML process, I said machine learning, the ML process will normally have the following things. First of all, you have to define the problem. You have to, every problem will have three things in it, three parameters. The first one, we call it as a task. Task is what is that you want to do? Okay, task means the problem definition. What is that you want to do? You say, I want to predict whether it is going to rain today evening. That is my task. I want to find out this robot to climb the wall. How many iterations will it take? How many times will it fail and how many times will it succeed? That is a task. Okay, what is that you want to do? You call it as a task. And the next parameter, we call it as experience. Experience is nothing but the training data. Okay, training data, what you give as an input for the system to remember, for cognizing, the training data will act as experience. That is a database in case of ML process. And then performance. Performance is like you always have to know how well it is responding. Okay, to what extent it is reliable. You say, you take the picture of human heart today, and you say, I'm doing some mining method, I'm doing some ML process, and you say this heart, after 10 years, there'll be a heart attack on this heart. If you want to do a prediction like that, okay, what percentage of your prediction is going to come true? And what are the performance measures you have considered to make a prediction like that? Everything will matter, and that is called as your performance. Performance will always have one component called as a metric. Metric is a measure for performance. Different type of application, different type of processes will have different type of metrics for their representation. The next issue is, why is that a problem needs a solution? Okay, so that you have to analyze when in your ML process. So what are you trying to solve? You have to have a clarity on that. What is the solution? You have the solution with you. Supervised learning method says that I have the data, I have the solution, I'm designing a method to see whether I'm going to get the right solution. Okay, that is your supervised learning, and that is what we say. Why does this problem need a solution? Do you already have a solution? Are you designing only the model, or you're designing the solution? Okay, that everything, all these complexities could be included in your ML process. And one more important thing with ML process is you have to collect data. If your training data is perfect, only then your prediction is perfect. Only then the model what you apply is correct. The test data what you give is correct. Okay, so if the data what you have collected is 100% correct, leading to some solution, only then you can process. So this is a very important step of collecting data. Maybe to collect data, it depends on the application. There are different hurdles when you have to make the databases. Once you collect the data, it's not sufficient. If you start processing, you have to do a lot of things on the data. We call it as pre-processing, wherein we do cleaning of the data, formatting of the data, and we do sampling and a lot of things. You prepare the data for analyzing purposes. That is the next step. And then sometimes we split the data into training data and test data. Okay, you say which data perfectly leads to the solution. We call it as training data. Test data is you want to know the solution. Okay, you have all other parameters. I want to know the solution. That is test data. I'll give you an example. Okay, training data means, suppose today's climatic condition, morning the temperature was so much, afternoon it was cloudy, evening it has rained. Yesterday morning again it was sunny, afternoon it was cloudy, evening there was no rains. Like this, day 1, day 2, day 3, like that, I take around 30 data about different climatic conditions, and I put it in the database. That is training data. Today I want to check whether it is going to rain or not based on the training data. I say morning it was sunny, afternoon it is cloudy, evening will it rain or not? Question mark. Evening will it rain or not? Question mark. Now this is my test data. What do? I go back, I see yesterday, day before yesterday, and 30 days, what was the data I had on the training data set. Did it rain in the evening? I come to a conclusion, and based on that comparison and all that, I do some algorithms, I do some analysis, and then I say, in my test data, today evening, it is going to rain. Test data is the data what you want to check. Okay. Training data is proven data, which is available for analysis. So you have to bifurcate the data, what is training data and what is test data. And we have different algorithms here like decision tree, naive-Bayes, ANN, regression, and much more. We do have training algorithms. You have to make an algorithm. You have to design a model based on the application, based on the input, based on the training data, based on the test data. You have to design a method which is called as an algorithm. We evaluate the test data and we do parameter tuning and lot more things here. It doesn't end here. And getting into one wide field of neural networks. As I told you, your machine learning or whatever, most of the things in artificial intelligence work like how our brain work. Okay, so we try to analyze this neural network type of representation wherein we have the component of cognition and recognition. And as you know, as I explained earlier in my presentation, your neural network representation is like neurocomputing, making a system work like our brain, like how our brain works. You try to map that onto the machine using these ML techniques. So your neural networks, as you know, we have got different layers, the input layer, output layer, and hidden layer. More the hidden layer, more is the knowledge. And then ordinary neural network doesn't work with it. We get into another representation, we call it as a deep learning. And that again leads to many more things. To look into the multidisciplinary neural network representation, this slide shows what are the different areas of neural networks and what neural network will take as an input. So neural network is one big area of artificial intelligence, more of mathematics, okay? And you can see this slide. These are different applications and where all it could be applied. We say neurobiology, cognitive psychology, linguistics, philosophy, and most of the things neural networks will be, we can apply neural networks to on these areas, and you can work with this. You can say, I just want to do cognitive psychology, like how is that I recognize things. You would have heard of sentimental analysis and all that. Analyzing the online behavior and making some decisions on that. All these stuff could be applied and could be analyzed with your neural network type of representation. Now getting into the next slide. Okay, why is that now you started talking about machine learning and what are the different areas of machine learning and how is that you classify the machine learning algorithms? That is all about this slide. So you can see like this is a very common thing. You would have heard of big data representation. So data nowadays, if you write an algorithm to analyze small data, the same algorithm doesn't work to analyze big data, right? So big data representations, you know the different V's we have: velocity, veracity, and veracity. What happens here, it's not only limited to 3 V's, we have got 7 V's, we say. Complexity of data, the enormity of data. Mostly, no, it is about the content, how much content it has got, how much MB of data you have. The enormity of data led to this concept of big data representation. Now, if you want to write an algorithm using ML for big data, it is not the ordinary algorithm. Definitely, when the data is huge, when the data is complex, obviously the technique, whatever you're going to apply in your model, will also change. Fine. So why is that we need now? That's because data is flooding, you know, with the wind of internet and all these things. If you want, just get into how many tweets you have in a day on Twitter, how many photos are uploaded on FB, managing the data, holding the data, everything is a challenge. Okay, everything is challenging. So that we call it as a flood of data, enormity of data. And increasing computational power and all these things, you know, these are very common things. And definitely we have the concept of cloud also here, and all these things have led to this way of thinking using machine learning. Here we have got two major things. You can see in this slide we have given only 2 things: supervised learning and unsupervised learning. We have got 2 more subdivisions. We call it as semi-supervised learning and reinforcement learning. Okay, so that I'll explain in the further slides. So right of as of now, you can see here we have 2 types: supervised and your unsupervised type of learning methods. Okay, so under supervised we have got classification and regression. Under classification we have got support vector machines, discriminant analysis, naive-Bayes, nearest neighbor, neural network. All these representations are classification type and they are under supervised learning. Now, what is supervised learning? Okay, that should be your next question. That should come in our mind next. Why do you call it as supervised learning? I'll give you a simple example. If I want, okay, to identify the person with this photo, given the names, okay, we call it as supervised learning. That is, the input is given and the output is known. Okay, the data, whatever you have in supervised learning is such that the input data and the output data is known. You're thinking of a model to get the best possible result. So data is already known. We call it a supervised learning method. Under this, you have got classification and regression. Regression is more of mathematical type of representation. In regression, you have got neural network, decision tree. Again, we have got different SVR and GPR type of representation. We also have linear regression. I have a separate slide on regression. We will discuss in detail. Later, the second greater part of machine learning is your unsupervised learning method. Now, unsupervised learning method means, I'll give you an example. The data is known, the result is not known. Example for that could be something like, I want the my machine learning algorithm, okay, given to a computer. I want my system to identify the different celestial objects, and I want that to give me a pattern, what is being generated on its own. Okay, so the pattern what is generated and the result what is given, it is given by the machine itself. I have not recorded anything and given prior to the system. I want the system itself to do the pattern recognition, identify these celestial objects and give a representation for that. So when the data is not known and you're trying to generate that, it is more of unsupervised learning. Unsupervised learning is a very standard representation wherein data could be dynamic in nature. Data can get into the system as and when new data gets into the system, it will get recorded. The database will get trained for the new data, cognition happens and everything happens, and that new results, whatever you get, every time the new data gets added, the result structure keeps refined. In unsupervised learning, the result structure gets refined every time. So clustering classification is a very common thing. Classification is, I have all data, I bifurcate the data. I make them into groups and then I do a prediction. Clustering, I have clouds of data. Okay, I have groups of data. I'll give a label for those groups. And when a new data enters, I will try to identify this resembles cloud 1, cloud 2, or cloud 3. And then I put that into the appropriate cloud. That we call it as clustering. So K means K-medioid and fuzzy type of representation, hierarchical, agglomerative, decisive representation. All these could be done, including your Markov and your Gaussian representation. All complex representations are possible with your clustering type of representation. Clustering is an unsupervised machine learning method. Naina ma'am, is everything okay?
Yes, ma'am. Everything is fine.
Okay, fine. So the next thing is issues in machine learning. What is challenging in machine learning? What are the things you have to understand in machine learning? What is that you have to address in machine learning? Okay, each one, these 4 points, can be one research paper. It is like that. You can think of why like this, what should be done in this direction? What are the algorithms that exist for learning only the general target function for specific training algorithm? We don't have things like this. For one algorithm, this is the training data. For another set of algorithms, another training data. So the training data keeps revolving around for us to do predictions. Okay, can you have a generic representation like that? Can you have a general target function? It's very difficult to do that. Okay, you cannot. So depends on the input, depends on the complexity, depends on the enormity of the data what you're going to give as input, and then how much training data is enough for you to do a prediction. Now I quoted an example. If I want to predict whether it's going to rain today evening or not, what did I say? I said I'll take around 30 days of data. I'll say morning, afternoon, whether it was cloudy, rainy, and what are the climatic conditions. Then I said evening it is going to rain. This is my way of representing. Okay. Does it mean 30 days of data is sufficient to do a prediction for today? How was that? Okay. How did I say that? Is there a perfection in that? Is there some percentage of reliability in that? Right? So how do you say it is correct? And how much training data is that? 30 days data is sufficient, is it? 3 days data is sufficient? 1 year data is sufficient? That training data, how much you should have to make what type of prediction? Okay, having a hold on the training data. See, you cannot just dump the data into the database, make it more complex and make it more, denormalized, and all that things happens in the database when you go on adding data. So then it's just difficult for us. So you have a count. How much data should be your training data? That is one challenging way. And that is one major issue in your ML. And then prior knowledge, what we say, you already have made some predictions with some prior knowledge. And how do you make the machine get that prior knowledge? How do you make the knowledge base? Okay, what is that model you apply there to make your knowledge, to strengthen your knowledge base, to improve the accuracy in your prediction? When you give a test data, you say this is the result, and what is the accuracy component there? That depends on the prior knowledge. How we are going to cognize data into the database depends on that. So that is another huge issue there. And then how do you reduce the learning task? Okay, the learning task should be simple, should be easily analyzed. A simple mathematical model should be able, you should be able to give a representation for that. And then that should have a scope of improvement. I go on adding new data, that should get trained again, and that should get again converted into the result. So how is that you give that cognitive representation and reduce your learning task there? That is one issue. And you can see here I have given the different bifurcations of machine learning. In the previous slide, we had only supervised and unsupervised. In this slide, I have got semi-supervised learning and reinforcement learning. All right. I have another set of slides with diagrams to show you how the semi-supervised and reinforcement learning happens. Now, I spoke about supervised and unsupervised. I gave examples. In supervised learning, I said, given names and given faces, you want to identify that particular person. Okay. So data is known, and you're going to see whether it is doing right or not in your supervised learning. And identifying celestial objects and giving a pattern generating on its own. You want the machine to do it on its own. Okay, that is the unsupervised example. Semi-supervised is a mixture of supervised and unsupervised. Okay, you have a little bit of training data, you have a little bit of solution, and you want the system also to do some analysis and generate some results. Okay, so there the target function keeps varying there. So even there we have got similar to supervised and unsupervised, we have got classification, clustering, text classification, and all these algorithms are there in semi-supervised learning also. And then the next most interesting and challenging field of machine learning is your reinforcement learning. Now, what robot, and I say this robot, how many attempts will it take to climb the wall? How many times will it fail and how many times it is successful? Or how many attempts will this robot take to climb the wall to be successful? If there's something like that, we call it as reinforcement learning. I'll give you a much simpler example. Okay, for reinforcement learning. Now, let's assume I'm staying in RNSIT, my college. RNSIT is in Uttaralli, Mangaluru, Rajarajeshwari Nagar. All of you know that. So now from here, I have a meeting. I have to go to a company in Whitefield. Let's assume I have to go for a meeting in a company for maybe some corporate related work, consultancy work. I want to go to Whitefield. They say now the time is 10:58, 11 o'clock. They say 11:45 there's a meeting in Whitefield. 12 o'clock there's a meeting in Whitefield. Normally in Bangalore, to go from Rajarajeshwari Nagar to Whitefield, it will take 2.5 hours. Okay. With full traffic, maybe half traffic, I go in non-office hours. In between, I go sometime in lunchtime or something. Maybe little less, maybe 1.5 hours I may reach if I'm very fast and all that. Now, the issue here is not the distance. There are different ways I can reach Whitefield from Rajarajeshwari Nagar. I go in the main road with full traffic. It is late. I choose the outer ring road and I try to go fast. Distance is double. Okay, distance is double, but the time is less. I want to reach in time. See, the parameter is set. What is my priority? My priority is to reach in 1 hour. My priority, irrespective of the distance, irrespective of how much petrol I spend, irrespective of all that, I just have a priority as time. setting your priority and then applying your ML method is called your reinforcement learning. You're imposing a rule onto the system, and then you say, for this parametric representation, how does my learning algorithm react? Okay, so that method. There we have got something called as Q learning, some refer it as quotient, and then we have something called as your convolution matrix and all that. It's a very interesting field. Reinforcement learning is a lot trending these days in ML. So to go further, so I'll go a little bit fast. It's 11 o'clock. We have hardly another few minutes. See, look at this ML. You all can see this slide. Deep learning, ensemble approaches. In neural network, we have got the following areas. And then we have got a rule type of representation, regression. And then you can see all these decision tree representation, dimensionality reduction, fine, and cleansing the data, and all these are different mapping type of representation. Mind mapping diagram, we call it as in machine learning. And why learn? We learn, right, to understand, to analyze, and then to make decisions. Similarly, you make the machines learn, okay? Give the cognitive capabilities to the machine and then use it for our requirement. And then this is again continuation about learning. I think I'll directly take you into the soft computing methods, whatever we have here. And one such area here in your ML methods could be your KDD. What does KDD stand for? Knowledge discovery with databases. Okay, knowledge discovery in databases. This is it's another synonym for data mining. So what is that we do in data mining? We try to identify unknown patterns. Okay, we try to come into some decisions based on some available data. So here you can see we have different applications like retail, finance, manufacturing, medicine, telecommunication, bioinformatics, and web mining. These are different applications of data mining. And of course, this is an area of your, you can apply DM representations in ML also. To get into the detailed contents here again, ML, what is that we try to do? First thing is we try to study the algorithms out of three things. You need to have three things in machine learning. One, algorithm. Second, performance measure. The third one is to make some task based on experience. Okay, so these are the three important things we have. We call it as P, E, and T. P stands for performance, E stands for experience, T stands for task. Okay, P, E, and T, PET. Those three things are very much required in machine learning. So every time you're trying to work on that, you're trying to optimize the performance and based on the available statistics, and you're going to use some problem solving methods there, which is your model. Now, growth of machine learning, to go further, what are the different areas? When I started this lecture itself, I told you what all these areas are. Machine learning, speech recognition, right? So for speech recognition, we use natural language processing. When you talk, when you communicate, you use some language, right? So that one major field is your natural language processing. Computer vision, you see. Identify the patterns, image processing, and all that comes with your computer vision. Object recognition, object identification, convolution neural network, and neural network representation also go with computer vision. And then robotic control, computational biology. These are a lot of things we have here under machine learning approaches. And what is that which is trending these days? These are few things which are very trending listed here. These machine learning algorithms to capture data in a network using faster machines, and also for big data, and based on the demand of user customer satisfaction. These are different areas wherein you machine learning finds its application, which is very trending. Now, in terms of applications, if you look into machine learning, we have association analysis, supervised learning. In supervised learning, we have classification, regression, and prediction, unsupervised, and reinforcement learning. So we have been talking about learning associations. Okay, you say you make the machine learn in terms of association. In terms of association means what? Let us take an example of market basket transaction. Market basket analysis, we have something called as a probability. We say P y of X is a probability. I'll directly get into this example. All of you can see this transaction table. Those who have taught data mining, who have studied data mining would have seen this example. Okay, so you can see here TID means transaction 1, transaction 2, 3, 4, and 5. All these are transaction number of transactions. And in first transaction, the person has bought bread and milk. In second, bread, diaper, beer, and eggs. Third transaction, milk, diaper, beer, and coke, like this. Now here we are going to give beer slash, okay, so there's a mistake here. So it should be slash diaper. So the meaning of this probability is like this beer and diaper combination has occurred how many times? If you look into here, transaction number 1, 2, 3, fine. We have 3 transactions for beer and diaper 1, 2, 3, 4. Diaper, we have got 4 transactions. Now, out of 4 diaper and beer, 3 times beer has occurred along with your diaper. So the occurrence of and the percentage, we say the probability is 0.75. To get into the next one, other than learning with association, we can also make the machine learn with classification. Okay, you can see here there is some data classification made for credit card score. This application or the slide is about the credit card score. Here you see there is a lower risk, and here you can see there is high risk. So he's trying to identify some areas where there is low risk, and he's trying to give a representation for this. We have a discriminant. We say income greater than theta 1 and saving greater than theta 2. So theta 1 and theta 2 along the x-axis and y-axis. X-axis is about income and y-axis is about savings. So this is data is being bifurcated into 2 divisions like low risk and high risk based on your component or the item values, whatever we have on income and savings. So this is one example of classification. To go further, the different classification applications could be on pattern recognition, face recognition. Okay, in face recognition, it's a very wide field wherein you see the pose, the lighting, the occlusion, makeup, hairstyle, everything matters to your face recognition. Character recognition, speech recognition, medical diagnostics, and web advertising. These are different applications. Face recognition, this is one slide you can see here. This is the training example. This is the test data. In this, you have to map which of these are available here in the training data. So just a sample for face recognition I got. And then prediction, I just told you regression is full of mathematics. Decide the slope. You have WX and WO here. You've got X and Y parameters here. So this is one method in your supervised learning method. Applications of regression is for your navigation car. You have something called as kinematics of your robot arm. So these are the parameters they define, and this is how it looks like. And when is that supervised learning finds its uses? Most beautiful example of supervised learning is about decision tree, the tools, and how is that we make predictions for the future cases, and how is that you do knowledge extraction on the data, and how is that we do the compression of the data and do the outlier detection. What do you mean by outliers? See, anomaly detection or outlier detection is one popular, most interesting field in supervised learning. So what happens is sometimes the data doesn't belong to any of the bifurcated classes. The data will be something outside, and then you want to identify it belongs to which class. Accordingly, the class definition is going to change. So that is one challenging area of anomaly detection. In unsupervised learning, what is very challenging is what normally happens, you try to identify. Output is not known. Okay, you're going to generate the output with clustering methods or any of the unsupervised learning methods. There are other applications also. We call them as summarization, association analysis, and it could be with customer segmentation using CRM, color quantization, bioinformatics are different areas. Reinforcement learning, as I told you, there are different policies here, and you don't have supervised output. We always have a revolved function. We call it as a revolve, and we call it as Q learning type of representation. So what are the applications and where is reinforcement learning widely used? Normally, reinforcement learning is widely used in your Robert Mays problem or your game playing and multi-agents and partial observability type of representations. Okay, dear participants, from where did I collect all this information? This is the data sets, UCI data set and all this. You can use this. Those are doing research can use these data repositories for doing their projects. And these are different journals wherein this data, whatever I have collected, is available. And some of the conference data also, right? So then I have one small video for you. And just before I get into the video, I want you to come up with another presentation. Naina ma'am? Hello?
Yes, ma'am. Yes,
Yeah,
ma'am.
ma'am, can you all see my slide? I have changed the slideshow.
Yes, ma'am. Yes.
What is that you can see on my slide?
Introduction.
Yes. Okay. Fine. So here I'll be taking you, see, dear participants, since I have spoken all this time and the PPT is not available with you. I know definitely each one of you would be interested if you want to learn more on basics, you want to learn more on regression or clustering, where do you get the data? I have these contents here to give you the source where you get all this content. Like now, since I spoke about artificial intelligence and machine learning, definitely the first question, how many people have heard about machine learning? Obviously, yes, everyone knows. And how many know about machine learning? Obviously, you will say yes. And how many are using machine learning? Probably very few. Now onwards, you will start using. And about this one, as you know, machine learning is a subfield of artificial intelligence. Fine. And who was the father of artificial intelligence? Any of the participant? Can you answer? You can unmute just to see you're active. Who's the father of AI? Don't Google. Naina?
John McCarthy.
Yes. Good. I think all of them will know. Probably in chat they would have told. So this slide, fine. It gives you the details about machine learning, how it's a theoretical concept and all that. So as I told you, see, this is very, very important. Anytime, anywhere you want to say what is machine learning, in 3 words you have to say experience E for some class of task T with the performance measure P. Okay, so these 3 things matter to make your ML or to make your computer program learn. Okay, so that is the whole story about machine learning. Now the different terminologies as per the definition given with P, E and T goes like this. We have different features, we have different samples, we have something called as a feature vector, we do feature extraction, and then you have got the training data, which you call it as an evolution set. Now why is that you call it as an evolution set? Evolution set we call it because as new data will get added to the existing data for further analysis, we call it as an evolution set. Okay, so to get deeper, say look at this is very interesting. The word apple, if I just say apple, what comes into your mind? What would be the parameters? So your mind, no? How is it trained? The word apple in your mind, how is it trained? Okay, so see, how does it learn? You say, this is also apple. Red in color, it is a fruit, round in shape. This is also apple. Sky blue, it is a logo. And this is yellow and it is a fruit. Fine. So your mind works like that. Now, how actually workflow? What is the workflow that is happening in your mind? Initially, there's a label given to that. Apple is a label given to that, to the machine learning algorithm. Input. Okay, input is this. Color, type, shape. That's the input. Features. you give different features, color, shape, okay? And these features are processed and given into the machine learning algorithm that enters a classifier model. The classifier model is required for doing predictions. You've got a feature extractor here. Again, this is for prediction also, you have an input. Here I've got training data in A. B, I've got test data, okay? Test data has to tell whether it is an apple or not. Can you look at this diagram? I started with label, apple. I applied all the available things. I'm going to predict whether it is an apple. Understood? Because apple, this is also apple, this is also apple. In this, I'm going to enter what type of apple it is and what is that you want to predict. So this is one simple slide to give you an idea about how feature extraction, machine learning, and how is that you have classifier models. Categories of machine learning. Okay, so this slide we have already told. Supervised, semi-supervised, and reinforcement learning, unsupervised learning. You can look into here. In supervised learning, the correct classes of the training data are already known. So this is an example of supervised learning. So you can see here, there is a sample data algorithm applied. And you want more details on this, it's available on this website. Unsupervised learning, the correct classes of training data is not known, okay? The data is not known. You're going to apply and you're going to do some prediction. You want more on unsupervised learning, you can enter into this website. You'll get all the details. Semi-supervised learning, you can see here, okay? It's a mix, it's like hybrid type. You have some sample data, you're doing some type of prediction, fine? So more on that available on this website. Reinforcement learning, as I told you, allows the machine or the software agent to learn the behavior based on the feedback, okay? You get a feedback, you take the feedback and see it's correct or it's not correct, how much time will it take and what are the parameters required, and then give it as an input to the next level. So reinforcement learning is very adaptive in nature. You can customize it and it is very, very powerful compared to other three methods of learning. Depends on the application. Now here, as I told you, if you have to prioritize, okay, you say you have some parameter as your preference, then you go for reinforcement learning. Want more details, you can get into this. Machine learning techniques, as I told you, classification from observations, clustering meaningful groups. The third one is your regression for predicting observation. I won't talk much about classification, prediction and all. We are running out of time. I have a beautiful slide here and a video to show. So look at this. In classification, we have got naive-Bayes classifier. You want more on naive-Bayes, you can study. Clustering, it could be, see this example for clustering is very interesting. You can see here. You're saying you're going to make a group of objects. These are the keywords you have identified in the group of object. Man's shoe, woman's t-shirt, man's t-shirt. What are the different categories you identify here? Shoe and t-shirt, or it could be man and woman. There are different types of clustering algorithms. We call it as majorly, see, clustering, unclustered. Here it is clustered. You can see the colors here, making them into different groups. Hierarchical, we have two types, agglomerative and divisive clustering. So when is that? You go for the first one. If it is a bottom-up approach, okay, we go for agglomerative clustering. The complexity is O in Q. And when it is your top-down approach, we go for divisive clustering. Tree-like structure. Okay, you've got the root node and you've got the siblings and all that. We go for divisive type of clustering. Decision-making type of representation. Complexity is 2 to the power of n. It's also available here. Regression. This is the slope and regression. I have already told you, and with an example, we try to do predictions with logistic representation. We also call it as regression with binary representation. The difference between classification and regression, here it's very clear. Here, classification means you have a group of output into the class. You have the output here. Here, you're going to predict the output, okay, using your training data. So this is a sample like how you can do difference between your classification and your prediction. The most important thing here in classification, the data is discrete and categorical type, the variables. Here it is real numbers and it is continuous in regressive type of representation. So use cases with your ML, your spam email detection, machine translations, image search with similarity, clustering in your Amazon recommendations, and your Google News is a classification example. Amazon representation is your clustering example. Image similarity, if I say Taj Mahal, I get Taj Mahal hotel, I get Taj Mahal on a picture, I get real Taj Mahal in Agra, everything, right? So that is one challenging area of similarity in image search. And much more use cases, your Google News. It could be text summarized, okay? Help your credit providers with your fraud detection, and your bank and insurance sector in your decision making or your sentimental analysis. Analyzing the online behavior of a customer and giving him suggestions, buy this, and all that. That is your sentimental analysis. Your iPhone Siri is your speech understanding, okay? And your Facebook photo tagging is your face detection. So one thing I want to tell you above all this, I have got one beautiful, let me go into my previous representation.
Manage data from 5 continents.
Artificial intelligence for people in a hurry. The easiest way to think about artificial intelligence is in the context of a human. After all, humans are the most intelligent creatures we know of. AI is
Ma'am, Naina ma'am, can you see the screen?
Yes, ma'am.
Naina ma'am, is it audible, you tell me?
a broad branch of computer science. The goal of AI
Is it audible, ma'am?
create systems that can
Yes, ma'am.
intelligently and independently.
Okay, dear participants, this video is very interesting, and what all I spoke for past 1.5 hours is summarized. It is just for 2 minutes. You can look at this. It's very interesting.
Hurry. The easiest way to think about artificial intelligence is in the context of a human. After all, humans are the most intelligent creatures we know of. AI is a broad branch of computer science. The goal of AI is to create systems that can function intelligently and independently. Humans can speak and listen to communicate through language. This is the field of speech recognition. Much of speech recognition is statistically based, hence it's called statistical learning. Humans can write and read text in a language. This is the field of NLP, or natural language processing. Humans can see with their eyes and process what they see. This is the field of computer vision. Computer vision falls under the symbolic way for computers to process information. In another way, their eyes, which create images of that world. This field of image processing, which even though is not directly related to AI, is required for computer vision. Humans can understand their environment and move around fluidly. This is the field of robotics. Humans have the ability to see patterns, such as grouping of like objects. This is the field of pattern recognition. Machines are even better at pattern recognition because they can use more data and dimensions of data. This is the field of machine learning. Now let's talk about the human brain. The human brain is a network of neurons, and we use the brain, we might be able to get cognitive capabilities in machines. This is the field of neural networks. If these networks are more complex and deeper, and we use those to learn complex things, that is the field of deep learning. There are different types of deep learning in machines, which are essentially different techniques to replicate what the human brain does. If we get the network to scan images from left to right, top to bottom, it's a convolution neural network. A CNN is used to recognize objects in a scene. This is how computer vision fits in, and object recognition is accomplished through AI. Humans can remember the past, like what you had for dinner last night. Well, at least most of you. We can get a neural network to remember a limited past. This is a recurrent neural network. As you see, there are two ways AI works. One is symbolic-based, and another is data-based.
Okay, ma'am?
Yes, ma'am.
Yeah. I would like to take questions.
If anybody is having any questions, we have the Q&A session now. You can either put the questions in the chat section or you can turn on your mic and ask. Ma'am, we have a question from Shrikant NG. He's asking how it can be used in spam mail email detection.
Okay, email detection, fine. I can share the content with you, the detailed content. So I'll just give on my chat, kva@gmail.com. Okay, I have just given my mail ID. I'll share the complete content like in your email detection, how it actually works. I have the complete set of slides I can explain. What exactly, how can be used in spam email detection, ma'am? Okay. So normally, the contents get into the spam. In 2 lines, I'll tell you. How is that the contents get into spam? So the ones which you frequently don't visit, like how I gave you the example of Netflix. Even if before you watch the movie, okay, even before you watch the movie, the review is available. So there is an AI-based thing working there, wherein which the ones which are out of your interest, the ones which you have already blocked, normally you can write a ML process to spam them. Okay. And one more example I would like to give you, like even in your Facebook, the ones which some of the friends post, which you frequently like. Okay. So that those feed will appear before the other ones. Based on the count, they will appear before the other ones. That's also like your AI application engine. And one more example I'll give you similar to this spam. See now these days, because of this lockdown and all, most of the placement companies, they are doing recruitment online. All of you know, you will have online test. Even for you to write your internals, you will write online. Now, when they conduct this online test, these company guys conduct this online test, they say it is AI based. What is that AI based in this online test? When a student answers question number 1, okay, if he answers it correct, the next question, the difficulty level of the question is much more. If the first answer the student will answer wrong, the next question which appears, the difficulty level will be lesser. So that issue, we call it as AI based. Like this, you can apply some strategies and you can make the system AI based. Whatever you have, you can make it AI based. Okay. Spam is one simple example like that. And I have shared npkavya@gmail.com. That is my mail ID. All of you guys, if you want more information, you want to do research in this area, or you want some material related to this, everything I can definitely share with you.
Ma'am, we have one more question from Mr. RK. How artificial intelligence reduces the user experience using K-mean clustering?
Okay, see here, your question has two different things. K-mean clustering itself is a AI method. Okay, since machine learning is a field of AI, your question is how AI will reduce the user experience. See, K-mean clustering, in what happens in K-mean clustering actually, you have got different clouds, you have got different clusters, we say, cluster 1, cluster 2, and cluster 3. Okay, I'll get into the depth of your K-mean. So in cloud 1, if I have got 10 points, in cluster 1, okay, cluster 1 I have 10 points, in cluster 2 I have got another 10 points, cluster 3 I have 10 points, let us assume. When in cluster 1, those 10 points, out of those 10 points, the center point, I'll call it as a mean. I'll calculate the mean and then I'll make a boundary for the cluster 1. Similarly, in cluster 2 with 10 points, I'll have all the points there. I'll calculate the mean of that and I will make a boundary for the cluster. Now, since it is clustering, okay, it is not classification, remember, it is clustering. The inputs are known and you want to predict what is the result. A new item enters into this. I have cluster 1, cluster 2, cluster 3. The new item, you will see how much it will resemble cluster 1, how much it will resemble cluster 2. We call it as similarity index. Based on the similarity index, I will try to put that into either cluster 1, cluster 2 or cluster 3. Is that right? So now, your artificial intelligence algorithm user experience means here the data what is already available in the cluster, you call it as user experience. The training data what you have fed into cluster 1, those 10 points are your user experience. Okay? If your user experience is less, the number of points in your cluster is less. The similarity index obviously will be less. Okay? So you have a component of similarity and dissimilarity index. So how similar is that item? You put it in that particular cluster. The result of cluster 1 will be some prediction. Result of cluster 2 will be another prediction. So user experience is your input training data. And what you want to predict is your test data. RK, have I answered your question?
RK? Ma'am, we have one more question.
Yes, ma'am.
We SVM and YOLO algorithm in object detection.
Ma'am, come again. Hello, ma'am.
Yes, ma'am.
Come again, ma'am.
1 second. What is the difference between SVM and YOLO algorithm in object detection?
Okay. See, you're talking about SVM. SVM is your support vector machine. Okay, as an array, you store this data in the form of an array. And SVM technology is totally different. Support vector machines, we say. And your YOLO is a package. What you're going to use there? Okay, YOLO, you can refer it as a language for your object detection methods. I can give you, see, you cannot say the difference there. It's not right. Directly, you cannot say because SVM is a methodology and YOLO is this one, like more of a package or a technique like that. We use YOLO programming. Okay, so it's like that. I can share the content of your SVM. I can share the content of YOLO also. Using YOLO, I've got a project. I can show you a demonstration using YOLO. How is that we do object detection? It could be live object. Is that static object detection? Both are possible. I think I'm going through all the chat. Difference between Deepak has asked this question.
Yes,
What is the difference between SVM and YOLO? Deepak, get back to me on my mail. Okay, I'll give you content. I can show you a demonstration later on using YOLO. How is that we do object detection? SVM is a methodology. Okay, it's a methodology. I can explain in detail. We will do that. Get connected. I think that's it, ma'am. There are not many here, and can we wind up the session, Naina ma'am?
Yes, ma'am. Yes. We have our principal, Dr. Dilip Kumar K, to present the vote of thanks.
Thank you, ma'am, for your wonderful session. It was very enriching the knowledge of all the participants. Artificial intelligence and machine learning is a wonderful subject. And on behalf of SDIT Mission of Technology, I take this opportunity to thank you for your time and sharing the valuable experience. Dr. Kavya Aradhya, Professor of RNSIT, was kindly accepted our invitation to be a part of this wonderful faculty development program and shared the rich experience among the participants, and wherever the queries are asked, it was also addressed very nicely. Thank you, madam. Wonderful cooperation and support. And at the same time, I thank all the participants and showing their interest to join during this wonderful FDP program. Thank you for all the participants. And the session was such a kind, and the session is very wonderful session. And I personally thank Dr. Netravati and Professor Anand Upar for coordinating this faculty development program. It is a very fast-catching word, artificial intelligence and machine learning. I take this opportunity to thank Dr. K. Prakash. He is a person who is always supporting us, director of the institute, who is always supporting us to go and do all such wonderful activities. Thank you, sir. And thanks to all the faculties and the non-teaching staff who are supported for this. My special thanks to Professor Naina Yadav, Faculty of Computer Science Department of our college, for coordinating this wonderful FTP program. Thank you, one and all.
Thank you, sir. Thank you for those wonderful words.
Thank you, all the participants, and also my heartfelt thank to Dr. Kavya ma'am for sparing your time and giving us the knowledge. So many of our participants are asking for the slides, ma'am. So if you could provide.
Yes, ma'am. Definitely. I'll share the slides with you, and you can, you can share it with your students.
Okay, ma'am. So we'll be circulating all the materials to your mail IDs, and also your feedback form will be sending it through the mail. I request you all to kindly fill in the feedback form by 2 p.m. today. Thank you all for your valuable time. Thank you all.
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you.